Hello YouTube, RJ. Okay, we're on the bench. We're going to build the G3UUR oscillator. This is the circuit we're going to build. It's pretty straightforward, very typical G3UUR oscillator design for testing crystals. You can see it runs on 12 volts, and we've got a crystal down here with a socket where you can plug a crystal in and out. And you can see a very straightforward Colpitts oscillator here with your two equal capacitors, and nothing spectacularly interesting there. A little bit of decoupling here, 100 nanofarad capacitor on the power. The only thing, they have a follower here to buffer the output so we don't load this oscillator. But the difference in the G3UUR oscillator for testing crystals was this section right here. He's got the capacitor here, he puts it in series, a capacitor in series with the oscillator, which you normally wouldn't have. You'd have this grounded. And so what happens is when it oscillates, this offsets the crystal a little bit. What happens is when you throw the switch, you bypass, short the crystal. So you get two readings. You get two different frequency readings. And what happens is in his method of calculating the motional properties of a crystal, with the capacitor in and out of the circuit, the variation will be based on the parameters, motional parameters of this crystal. So you can actually calculate out your parameters by looking at the difference, plugging in the formulas. Then you get into the formulas for doing this. I'll bring those up and we'll take a look at them. Okay, so this is the formula that you use to calculate out your motional capacitance and inductance. CS is of course the capacitance of the capacitor that we short in to get our modified frequency. Of course, when you throw the switch and ground the crystal, you're getting the true series oscillating frequency. So CO is the capacitance of the crystal itself. You know, the actual holder is what they call the holder. So the crystal itself, you need to check that with a LCR meter or some kind of meter to check capacitance, get that value. You need to know exactly what your capacitance that you've got putting in series with the crystal in the circuit as CS. You want to use a meter and make sure you don't trust your labeling because it's pretty critical. So make sure you know this, make sure you know this. And then this is your delta frequency, the difference in the frequency. So when you open the switch, the change in frequency that you see, this is how much different between the two. Based on that, base frequency would be with the switch closed, grounding the crystal. So this is your frequency when the switch is closed. This is this frequency minus the frequency of the change, or vice versa. Plug this in, you come up with your motional capacity. Down here, you use this plugged in here. So 2 pi times the frequency squared times the CM over 1 will give you your inductance. Now, to use the software, the digital software that we're going to use, you can have either of these values. So you can calculate this value out and be done. You don't have to do this one if you don't want to. So, okay, let's get back. I'm using Manhattan building techniques, and I've got a little push button here I'm going to use for, see if we can get a look at that. I'm going to use for my button. So I've bent the tabs up so I can get it soldered into the crystal mount. I went ahead and put the crystal mount on. Let's see if we can get a view of that for you. It's just, I use, let me see if I've got them here handy somewhere to show. I use these sockets, the round little sockets for ICs. They work very, very well for this. Allows me to take a crystal, and let me grab a crystal over here. Show you what I mean. Let you take a crystal and just plug it right in. So it's real handy when you need a little jig that you're going to plug things in and out of. Excuse me. So if I can get this lined up. So let you just plug it in and pull it out. So that's mounted. The 2 outer pins. Center pin's cut off short. It's not touching anything. Let you get a little look here. So basically I'm going to take this switch and I'm going to solder it onto this pad, and then I'm going to solder it to ground, and that's where we're going to ground our crystal out with. And we'll go ahead and put our, when we're ready, we'll go ahead and put our capacitor there to ground. so I can bypass it with this button. So that's what we're going to do. We're going to put it right over here where it's easy to work with, and we'll go ahead and do that. Let me put just a little flux down there to make sure I get this soldered down well, both here and where I'm going to be putting the ground. That'll just help a little bit. So get him down and he should go on very easily. Tend the iron a little. Let's get him stuck to ground on this side. Got to get that copper plain hot. Big piece of copper. There we go. And you can see that. Maybe we'll roll this camera a little better. So nothing pretty, just a quick Manhattan construction technique. I'll go ahead and get some more pads. Of course, I'm using my super glue gel control. It's the best stuff I found for this. Make sure your board's clean, and it works fantastic. So I'm going to go out, use the circuit diagram. I'm going to go ahead and finish putting some pads down and start hooking things up, and we'll come back in a few minutes when I've got some work done. Okay, and we're back, and I've finished the build on the G3 UUR oscillator. Nothing pretty, but here it is. We're ready to start testing this thing out and see how it works. So what I've got here is I've got the oscillator, I've got the out and the ground tied up to my Siglent SDG 1032X using the frequency counter in it. Got 12 volts coming in from my linear power supply, or I will have. I don't have it turned on at the moment, but here I've got 3 of the 11.0592 megahertz crystals to play with. Over here I grabbed out a bag and pulled an 8.192 megahertz crystal over here out to try. And what I'm going to do is I'm going to move my bench camera over and get it set up looking at the Siglent up on the shelf, and we're going to power this thing up, put a crystal in, see what it does. So be right back. All right, there you go. You can see the counter. Let me do it clear here. Let's do a cycle off and on. Everything's 0. Let's go ahead and put in 11.0592 megahertz crystal into our holder. Power this thing up. And let's see what it settles into. Let's go clear the statistics. And we've got a good oscillation at 11.057, around 3.314. So now what we would do is we would write that down. We would push the button, see what change we end up with. Now we've settled into 11.055655 megahertz, or 654, let's say. So I'd write that down as my second frequency. Go to the button, it's going to change frequency back up, probably settle close to where we were before, I hope. Pretty close. So that would give us that. Now the only other thing we need is the actual capacitance across the crystal. So for that, I would use my LCR meter. I'm not sure what you would use, what you've got available. If you just don't have any accurate way or any decent way of reading, picofarad capacitance, they make some pretty cheap little meters. I've got one here that you can get. They've got some pretty cheap little meters. This wasn't very much. That work. You definitely, I mean, they're not the most accurate, the most amazing, but let's run over here. Let me adjust it and let me put it on picofarad and just let's see what this, I happen to know basically what this crystal is. Let's see what it reads. It's reading about 5.3 or so. Well, that's a little high. That's not exactly what it is. Of course, I have the big LCR meter, and it reads this as about 4.7. Some of these are 4.3 and 4. I find that most of these crystals in this format run somewhere around 4.5. If you just had to guess, if you wanted to do this and you just had to guess, I would go with 4.5 picofarad and run with that and see how you turned out. Can't guarantee you to be perfectly accurate, but put you in a ballpark. Let's drop another one and see how it does. It's coming at 11.05692, roughly 919. So that shows you there is some variations in crystals. They're not all the same frequency. So the true frequency is when you're pushing the button, just so you're aware of that. When you take that capacitance out, this is the true capacitance. So these are supposed to be 11.0592. So that shows you that there's always a little bit of variation in a crystal. It's never exactly the same. So let's try an 8 megahertz. 8.192 is what this one is supposed to be. We're working. It's not pretty, but it works. Pretty simple, pretty cheap to build. Couple 2N3904s. I showed you a schematic. You can do a screenshot of that and run from that. A few resistors, a couple capacitors. Bob's your uncle. Need a switch or a push button. I would try to stay something that doesn't have a lot of capacitance in it. The whole idea is here you want a clean short with almost no capacitance. So this little button is good because it's surface mounted. There's going to be everything's short. Leads are short, contacts are short, so that helps. But this is how it works, and this is a handy device to have, and it'll help you get this done. If you don't have the spectrum analyzer, if you don't have the frequency counter, that'd be okay. What do? I build this, but I've got no frequency counter. Well, if you go to like AliExpress, you can find some 8-digit LED inexpensive frequency counters that run about $12 that actually work halfway decent. The ones I've played with tended to be fairly accurate enough, I believe, comparison wise. They're cheap and they're easy to use. So pairing that with this would make a great device for doing that kind of thing and just be a handy device to have around. So there are other ways without all the expensive equipment to do all of this. And, I try to keep that in mind when I'm doing this. And I do want to, from time to time, get away from the more expensive lab equipment for someone who's just kind of doing this on a budget, or it's just, it's not a big hobby for them. And I'll try to keep that in mind in the future as I do videos. I'll try to come show you alternative ways of doing things on the cheap. So we're going to be moving forward doing our crystal filter in upcoming videos. That's what this is leading up to. I'm going to use this to sort crystals, and I'll show you how we're going to do that. I'm going to show you how we design our crystal filter in the coming videos. So we've got to have a crystal filter for our transceiver, and we need to build it. So we're going to need to do some crystal matching. We're going to need to do some reading some parameters from these crystals so we can use it in our software to design our filter and get it very close in the ballpark. Hope you enjoyed it. Hope you learned something. Hope to see you in the next video.